Assalamualaikum and good day everyone. I am Fatizati binti Muhammad Syari and me and my teammates representing to you our CHM256 presentation, Volumetric Analysis in Food Industry. We chose titration in acidity of juice as our main topic. And here is the content that we will talk through the presentation. I will do the intro part. For explanation of application, Farisha, Wan, Sofia will handle it, and conclusion will be discussed by Jemima. Before we start our presentation, I want to ask you guys something. Every time we drink juice and taste the sourness of it, do you ever wonder the acidity of the juice we consume? Because for your information, acidity is a key factor in determining the flavor, preservation, and overall quality of juice. To measure this acidity, we use a technique called titration, which allows us to quantify the total acid content known as titratable acidity. The objective of this presentation is to determine the total acidity in fruit juice sample using titration.
So first, we have to know what is actually a titration. Okay, titration is a method or a process to determine the concentration of a dissolved substance by adding a liquid reagent of known concentration until a given effect, such as a color change. As an example, the colorless solution turns into pink, which this tells us that it indicates that the reaction is already complete. So what is the purpose of titration? The purpose of titration is to determine the concentration of unknown solution. Titration is often used in food processing industries, such as it is used to determine the amount of salt or sugar in a product, and also to determine the concentration of vitamin C or vitamin E in a fruit juice. So, in our study, we are going to give an example how to determine the concentration of vitamin C and vitamin E in the fruit juice. Now I would like to explain what is the type of acid-base titration and what is the indicator that suits them. First, we have strong acid and also strong base. We can use any indicator to titrate them. And then for strong acid and also weak base, we can use methyl orange. And then for weak acid and also strong base, we can use phenolphthalein. And for weak acid and also weak base, it is not suitable to use any indicator. And we have to know what is the type of titration that we should know. First, we have acid-base titration. In acid-base titration, we have two types, which is back titration and also direct titration. And then we also have a precipitation titration. Then the third one, we have complexometric titration, and the final one is redox titration.
Now, we're gonna talk about methodology. First of all, we must know what material that we use for this experiment. First, we need sample juice. We also need sodium hydroxide or NaOH solution in standard base, phenolphthalein indicator, burette, pyrite and volumetric flask, analytical balance, distilled water, Erlenmeyer flask or beaker, white tile if you want a better visibility of color change, and last but not least is weaving board or paper. Next, we're gonna talk about preparation. First, if the juice contains pulp or other solid particles, filter it to obtain a clear liquid. Second, measure a 25 ml of juice sample using a pipette and transfer it to an Erlenmeyer flask. Third, rinse the burette with distilled water followed by a small amount of the NaOH solution to ensure there is no contamination. Fourth, fill the burette with the standard NaOH solution, ensuring there are no air bubbles trapped in the burette or its nozzle. Record the initial volume of NaOH solution. Fifth, add 2 to 3 drops of phenolphthalein indicator to the juice sample in the Erlenmeyer flask. The solution will remain colorless in acidic condition. 6. Slowly add the NaOH solution from the burette to the juice sample while continuously swirling the flask. 7. Watch for a color change from colorless to pink, which indicates the endpoint to the titration. The appearance of a faint pink color persisting for about 30 seconds is considered the endpoint. Lastly, record the final volume of NaOH in the burette.
I will share to you about example of result. Most of the acidity in natural fruit juices come from the presence of organic acids. Most foods, for instance, have citric acid, which is a tricarboxylic acid. I also provide the formula to calculate or formula to use to find the acidity of the juice. The formula for acidity involves multiplying the volume of titrant by the molarity of titrant as well as multiplying by the molecular weight of the acid that found in our food and divide by volume of sample, which in literation we need to titrate the sample at least 3 times to maintain the consistency of the sample. And here in this slide, I provide to you the outcomes of titrate sodium hydroxide to change the color of the juice sample to pink. The titration was carried out on 3 times with an initial reading of 0 each time. The volume of sodium hydroxide used in this titration is determined by subtracting the initial reading from the final readings of 17.4, 18.1 and 17.3, and the average volume sodium hydroxide was used in this experiment is 17.6. Once we have determined the mean volume of sodium hydroxide, we need to input everything into the equation itself. The mean amount of sodium hydroxide we used was 17.6 ml, which needs to be converted to liter to be 0.0176 liter. Following, the sodium hydroxide molarity was 0.1 molarity and the citric acid molecular weight is 192.124 gram per mole. Lastly, the sample juice volume is 25 ml, which also need to be converted to liter at 0.025 liter. The last answer, which is the acidity itself, was 30.53 gram per liter.
So, in conclusion, titration plays a pivotal role in the food industry, especially in determining the acidity of juice. By carefully adding a standardized solution to the juice sample until the endpoint is reached, the exact concentration of acid present in the juice can be calculated. The acidity of juices, often expressed as pH or titratable acidity, not only influences the taste and sensory characteristics, but also plays a role in preservation and microbial stability. Overall, titration in the acidity determination of juices is a fundamental tool in the food and beverage industry, enabling precise control over product characteristics, ensuring consistency, and ultimately delivering high-quality juices to consumers. This process enables food manufacturers to maintain quality control, ensure flavor consistency, and adhere to regulatory standards. By leveraging titration for acidity analysis, producers can fine-tune formulations, enhance taste profiles, and guarantee product safety.